Okay.
Times 10 to the negative 14.
And the live stream is up and going.
1 times 10 to the
And this is going to be so awesome.
Mr. Newfeld, I watched the live stream from last class.
Did you?
Yeah,
Was it good?
it was pretty good. Except I didn't finish the last 10 or 20 minutes of it, but
Why?
That was the best 20 minutes.
because I'm gonna go over those questions another.
Oh, so you gave up.
No, I was just super tired.
Yes.
Listening to one of my lectures, I found out there's a member of this school who's been listening to my lectures. He's never attended one of my classes.
Who?
And he's been listening to my live streams the whole time. He plays them during prep as background music for fun.
Who?
I'm telling you again, because I feel that reflects badly on him. What are you doing?
Yeah,
He's
it
been
kinda
doing
does.
it since grade 9.
What?
How does he know about this?
Actually, no, 3 years, because he's in grade 11 now.
For like a different class? Like, is he like going chemistry as like
Yeah,
background?
random
It's
ones.
just background.
Yeah, background noise, just listens.
Is he smart?
How do you even find out?
He might be a
That's
little,
terrifying.
Hey,
You just copy
neurodivergent,
them all the
but-
time.
Mr. Newfeld,
yeah,
I was a bit confused about
Just
what A
soothing,
was.
just white
and
noise.
a generic base,
It's been.
A
a generic base,
and HA?
generic acid.
That's
Weak
terrifying.
acid.
I'm so
Why is
scared
it
of
H
that.
then?
H what?
What's the H for?
H plus?
No, HA.
Oh my God.
H. What are you talking about?
KB is equal to OH. That's the base.
Oh, HA is the generic acid,
And then what's A?
the generic base, the conjugate base. Now that I have got everything up and going,
Do you think this individual's gonna hear you talking about it?
maybe.
When he listens to your prep?
Yeah, he does have like 4 classes to choose from, but also prep every night, so I don't know how much he actually gets through.
so scary.
What was it? Oh, HA. Like HA
That's listening in.
goes boom, boom, H plus A minus, right?
Yeah.
A minus plus H2O goes to HA plus OH minus. The generic acid case and the generic base case. You can also react it with water and get H3O plus, but it's the same reaction. So that's what we meant last day. What's the relationship that goes back and forth through here? What's the calculation?
1 times 10 to the negative 14 is equal to concentration of hydrogen times concentration of hydroxide.
Yep. I'm going to put KW just because that's the universal case. And then this is the other easy one. What goes back and forth here? PKW equals pH plus pOH. So that was the last unit. We're going to need them all for this section. How do you go from H plus to pH?
It's negative,
I should put equals there. And then if I am going this way, pH equals,
it's 10 to the negative
pH.
pH.
So, Mr. Newfeld, HA is the conjugate acid.
Well, are you back here?
Yeah, the KB.
Are you doing last day's notes?
No,
Stop that.
I'm on your note.
This page?
Yeah.
There's no stop that.
KB, bottom
Nope,
right.
stop
bottom
it.
Right.
Nope, not. I'll do that after. Let's do this one. If you're going from OH minus to POH, how do you calculate that?
Same thing. Negative log.
Negative log of OH minus. And then if you're going back up, it's 10 to the minus POH. Concentration of OH minus. Now, this is done very roughly. I didn't put the things and equals, but we need this. This is new from last day. And since you weren't here, I'm a little confused, we derived, this is calculating the Ka. So if you have HA plus H2O, do the full one, goes to H3O plus A minus. Then what is the Ka for that?
Ka is equal to H3, a concentration of H3O plus
Yeah.
times the concentration of the acid or
A minus. That is the,
base. Conjugate
yeah,
base
A minus. So the product of this reaction, yep.
divided by HA.
There you go. So you asked what that formula was. That's what that formula is.
Oh.
And then in class yesterday, we used both. We used these formulas to derive this relationship. So that is a new formula from yesterday. Kw is Ka times Kb because it must be so. Because if you solve that for H plus, then and you solve that for H minus and substitute it into that equation, it all cancels out except for Ka and Kb. Okay.
Can you see it?
Good. Good.
Can you go back
Exciting.
up?
But it's so exciting. Scroll higher?
No, why did you?
Mr.
Oh, because he asked me to.
You need a scribe.
Hey, Mr.
You
Could
probably-
slow down,
oh.
please?
It's being live streamed. And I could give you with your hand, you could just take whatever notes you can and then like email me and I'll send you a copy of the like today's notes.
Or all the notes are online.
And all the notes are online. They'll be in different orders and different
Okay, I'll
writing
just
because they're
look
like
at
previous
mine.
notes, but yeah. Well, I mean, your hand is messed, so. And I assume your handedness fits whatever hand was hurt. You're right-handed?
Yeah, that's my good hand.
Yeah, stop doing that.
Huh? I'm writing with my left.
If you're going to injure a hand, injure your non-dominant hand.
Well, obviously.
Everybody knows that. Okay. Woo-hoo! This is the exciting part. Sorry, was somebody still writing? Okay, write the equation. Because guess what just came back? Ice tables! Because it's equilibrium. It's so exciting. But they're easy ice tables. The only thing that's in this unit that we've done is that eventually we're going to have to figure out the pH. But the molarity of the entire solution, is that an initial value or an equilibrium value? Not equilibrium. Because I will make up, like, oh, I calculated this and I poured in vinegar and I made a 0.5. So this is initial because it is the total of, I'm going to use the generic of HA. So I'll get vinegar and I'll make up a 0.5 molar solution. So whatever we tell you the molarity is, that is not, it's a weak acid, that's not the concentration of H plus. But if I measure the pH, like you did in the lab, like lot, we've made the solution, we measure the pH, we put in the pH probe, we take it out. What is that value? Equilibrium, or total, or initial. If I just measure what's there, that's equilibrium.
Mr. McCall, what's after a total of and then there's like a scribbler?
That's not just a scribbling.
Ask the computer what it is.
Oh, I already erased it, so I don't have to subject myself to that embarrassment. Total of HA.
Oh, it was literally just.
It was literally just a scribble, yeah. Okay, write the equation on top. It's so exciting.
You should do a shout out every class for the guy who listens to this every night. Hope you're having a good prep, bud. Just like every night.
Keep studying. Maybe I should get an ASMR channel.
Your son.
You just in your videos you just people think
move.
that stuff
Look,
is listening
No.
to it. It's like subliminal. like,
It's teacher ASMR. I would have like Russell papers, and you'd hear.
Equilibrium. Keyboard.
Why is there only 3 columns in Snowfell?
Oh no, somebody broke the lab.
Why is there not 4 columns? Well, let's write the equation. First, tell me the equation that you have.
CH3, COH plus water.
I'm gonna read the periodic table in a whisper voice. Calcium.
Yeah, H3O, H3COO.
We're missing some things.
HO plus.
Right?
CHO minus.
I said mine.
Did you? I didn't hear that one for sure. Okay, like grade 8s, which one of those don't matter?
Holy
I thought you said we needed to write H2O though.
No, for bases you absolutely have to. But if I remove that,
Bases, I thought you meant, oh.
right? This is the true reaction. This is a better representation.
Why for bases does it stay?
Because a base is a proton acceptor, and it needs a partner to accept a proton from to make hydroxide. So when it's by itself in water, that's water. If an acid, we accept the shorthand, this can go to H plus with CH3. And this is a liquid. So is it going to be in our Ka? No, so we can ignore it. So basically we just go, we don't care about you.
Would the H3O plus be just the H plus?
The H3O plus is just the H plus, yeah. It's just the concentration of, yeah. So what values do we write where? What's the initial value? What molarity do we 0.500 molar. What's the initial amount of H plus and CH3O minus? 0. When we just start, that's 0.5 molar. It hasn't moved over. So this is the whole, and I played music when I did this. It was like, oh. So standard ice table. What is the change?
Maybe a find change.
Well, no, if you do minus x,
Minus x. Which side has minus x?
the left side.
The left side. Because everything's on this side, so you can only take away. This isn't even like you've heard of like this is the 98%. This is 100%. So a little bit will go away. On this side we would have
Wait, do we have to balance it?
x. You do, but it's balanced.
Oh.
I picked one for especially your first one that's pretty balanced.
Wait, isn't there?
And almost every acid equation you're going to do is going to be 1 to 1 to 1 to 1 because they give off one hydrogen at a time. So the ice tables are easy. Following through, what gets written here?
0.5 minus.
Mr. Newfeld, why is there 6 hydrogen and then 4 hydrogen? Like that doesn't.
What are you talking about?
Oh,
It's not supposed to be H3O. He just like
What?
done.
What?
oh, because it's 8. Never mind. No.
'Kay.
Keep going.
Okay.
But
What do I write here?
Minus an x.
Minus x. Yeah. And what's here?
plus x.
No, plus x. Just 0 plus x is
X.
x. That is x. Now, for the next part, don't just write the thing with the x in it. Write the full Ka with the concentrations, because let's say you mess everything else up. If you show me that you know that, oh, the Ka is product, so the first thing I'd write is
H3O.
H3O plus, and you go through and you write all this out, then I go, oh, you have a proficiency there, and I can award marks for that and go at least give you part marks. Because you've shown me you can do this part. So don't skip this step. Don't start putting numbers. And I find, even when you go back and you're reviewing KQ, if you do this, you get in the habit of doing that every time, you're much less likely to make a mistake because you'll make the right things, the squares and the cubes, and you won't just skip something. Oh, so exciting. Okay. What do we write in for KA?
The number.
1.8 times 10 to the negative
1.8 times 10 to the minus 5. Now, I'm so nice. I gave it to you. If I didn't give it to you, what would you do?
Look at the table.
Yeah, just go to the table. So I was just being extra nice, put it in there because we're going to concentrate on something else. 1.8 times 10 to the minus 5. It wasn't 0 in there, so I don't have to worry about that. Equals what?
X squared over
X squared.
0.500 minus x.
Now, I have told you that you will never have to solve a quadratic in regular chemistry 12. So how will you solve it? What's the trick?
Multiply over and square root.
If you multiply that over, then you're going to get 0. Then you're going to have 0.5 minus x, and you're going to times 1.8 times 10 to the minus 5 times 1.8 times 10 to the minus 5, and that's going to give you whatever this is, blah, 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 minus blah, 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 x over x squared. You're still going to have an x over x squared. You're still solving a quadratic. That's not going to work.
Take the square root.
Solving quadratics is for stupid people who take AP.
Or like any math.
Yeah, because math people are silly.
What are the sound things on the side right now?
Oh, this is because true awesomeness is about what we're going to do if you don't get it on your own.
He's too awesome!
Awesomeness approaches.
Do it again.
What's the one that says thanks?
He's too awesome!
Watch this.
What's the other button?
In a second. That's after I show it to you.
Okay.
Yeah.
Okay.
So I'm gonna do it in red. Here's what you do. You say let, because you have to tell people what you're doing. Let 0.500 m minus x equal 0.500 m.
That's illegal.
What?
That's illegal.
Thank you. Thank you.
You just say.
That's illegal.
And then 1.8 times 10 to the minus 5 is equal to x squared over 0.500 molar.
So
x equals 0, then x squared is 0 squared.
There is no charge for awesomeness.
Oh my god, I know where that's
Just-
from. Why is it called thanks?
Because there's no charge for your thank you right now. I've shown you something. You can do this in math now.
It's Jeff
No, you can't.
And someone said x is equal to 0. No, it's not.
Why not?
X is right here. You're solving for it.
But you made it
No,
equal
you
to
No, I
zero.
didn't.
Yes, you
I
did.
made it not count where it would be irritating if it counted.
That means it's 0.
But that means
No,
X
no,
equals
no, no.
And then 1
Zero and no-
I'm literally, how did I make it 0? I'm literally solving for it. We're going to get a number.
But you solved for it before.
What?
You already solved for it above.
Yeah.
No, I didn't.
Yeah, you got 0.
Does this say what x equals?
Yeah,
Yes.
No, it
Yeah.
says what 0.5 minus x equals.
So
Well,
therefore
yeah,
x must be
Okay,
0.
okay.
Okay,
But if you rearrange that,
I'm going to give you an analogy I think will really help.
I don't.
We are
Your
taking
analogies are
a
fancy.
whole school photo. We're outside.
Today?
No, it's an analogy. We're outside, everybody's gathering, they've got the big crane, there's drones flying, and then someone goes, oh my god, someone forgot to tell the grade 8s. We'll have to wait half an hour here. Do we wait half an hour for the grade 8s?
Yes, we wait for
No, because they don't matter. They're not even real students. Who cares? They're grade 8s. Are they going to school today on Saturday? No, because they're useless. They are not real students. We ignore them. However, if we were taking the photo and we said, oh my god, a grade 12 isn't here, do we wait for them?
Yeah.
Of course. You matter. Next year, Mr. McPherson is going to ask you for money because you graduated, you're an alumni. Like, you really matter.
They ask you for money?
This, what?
Hell no.
What money? Like, are you actually necessary?
He'll ask you. You don't have to say yes.
I'm blocking him.
Now, this is a relationship. You've seen this before in grade 11. You didn't know that you saw this before in grade 11, but you did. If I gave you to the correct number of sig figs, what is I need more room. What is 0.500 minus 0.00000?
It's 2 sixes. Well, it's
What's the answer?
0.500.
No.
So as long as x is small enough,
How do you
when you're minusing it from a big number, you can just remove it.
How do you know
How do you know
that?
In this year, every case where you can do that, x will be small enough. We don't require you to check. When in university, we're required to check, and the answer is when x is 5% or smaller of 0.5 or whatever number you're minusing from. So as long as it's below 5%, you can totally do that.
If it's such a small value, does it even matter if we calculated it?
Yes, because that's going to tell you the pH. What it means is it doesn't matter that it's being minus from here because it is so small, but it will tell you the pH. We still want to solve for it, so we want to know what it is. So we still get a value for x, and that's the value used to compare. And when you compare in university, you go, if you solve for x and you make this assumption and you get like 0.1, you go, oh, I shouldn't have done that. Although I should have used like calculus or solved the quadratic or done something silly. But really, actually, you can get away with it because all you do is you go back and you use 0.1 and then you resolve it, and then you get a slightly better answer, and then you use that answer and you put it back in and resolve it, and you keep doing that until you get the right number of sig figs you want, and then you stop. And you don't even need calculus. calculus is useless. Calculus is so useless. So,
Calculus
if
is not what engineers like.
I was in chemistry, before we had computers that did the math for us, we would get graphs like on paper, and we would get an NMR. NMR is an MRI for molecules. So you get something like this. And these patterns, this shows me that's CH3, that's a CH2. It tells me the amount of the carbons and hydrogens in the molecule and how they're connected. I can derive the actual formula of the molecule from this NMR. And the area under the curve tells me how many. So I want the area under that curve. Now that seems, how many of you have taken calculus? That seems like the prime reason to have calculus. Get the equation, which you can do, and then just take calculus. But that's not what we did, because that's a waste of time. That doesn't mean anything. What we would do is we would get a square of the same graph paper that is a perfect square, so let's say 5 centimeters by 5 centimeters, and we would weigh it on a microgram scale. So this would be, say, 1.782 grams. And then we would very carefully cut this out. So we would go along with scissors, and then we would weigh it, and we would get like, I don't know, 0.875 grams. And then we would just go, oh, 0.875 grams over 1.782 grams is equal to x over 25 centimeters squared, and then solve for x to get the area underneath the curve.
That seems like a
We did it with
lot of work.
instruments. It was so much
Just
faster.
pretend.
So you have to get the equation. Like that takes work and like a whole other computer. Whereas this, we just cut things out with, kindergartners can do this. Well, maybe not the math part, but they could do the cutting probably better than some of us could. We also had a girl who was very popular because freehand, she could draw these graphs and they looked just like the machine. So I don't know, if you got, say, a 0% yield and you had to restart the graph, the thing you had to do to prove that you made the material in your synthesis was you had to show your teacher the graph. And if you just used up all your material to make the graph, then that's fine, you proved you did it. So she could draw them for you. So she would just be like, oh, you want this? And she'd get the long line of graph paper and go, she made a lot of money. Anyway, so yeah, you can figure out the area of the curve in very practically. If this is blowing your mind, and you're like, those stupid chemists, I can't remember the problem I was trying to solve. It was in honors physics, first year university, because originally I thought I was going to go into physics and not chemistry. Loved physics. They all smelled, I told the story. But we're working on a lab. And when we get down to it, we realize, wait a minute, we have two variables. This is completely unsolvable with two variables. Like, we can't get the answer. We go to a professor, did we forget part of the lab, what are we doing? And he says, oh, right, I forgot to tell you this. To the whole class, you have two variables. One of those variables is just a small number. So use E. You know the mathematical
Like you
E?
number.
Yeah, just use it.
What?
And we're like, what, is it E? And he goes, no, but they're both small numbers, so it'll work.
What is that?
And we're like, no, like, they're not the same number. And he's like, no, it will work. And we did it, and then the results came out accurate. Sometimes you just need something in the ballpark because it's small enough that the sig figs make any difference not matter. And that's what this is. The sig figs themselves take it, so this is just an expression of significant variance. This x minusing it is smaller than the error in the 0.5. But here, where it's not minused, those sig figs matter, so it stays. So it's not 0, it's just here, it's a grade 8 with prefix. But if the grade 8s were by themselves for their own class photo, yeah, we'd have to wait for them, because that's literally the whole point of having a grade 8 class photo. I mean, really, if we want to admit they're in our school. Doubts about that. So yeah.
Well, this was awful.
Just to be clear, Kirk is currently in grade 8. I've told this right to his face. Who knows? Wilbur was so excited when they started grade 9 because I told them this. They're like, yes, I matter. I'm in grade 9. And I said, yes, but you're grade 9. You don't count. You're a real student, but grade 9s don't count.
When
Yeah.
do they count?
Great time.
Great talent. Because have you ever tried to be a prefect with grade 10s? They're insane.
Our grade 9 is
Yeah.
insane.
Our grade 9s are good.
I find the grade 9s
Grade
better
nines-
behaved.
Our grade 9s are feral.
Oh.
No, our grade 9.
Maybe it differs. Yeah.
Yeah.
Our
we've
grade
never-
9s are reasonably good.
We've never had grade 9s that have been this feral. It's insane.
Okay. Now that I've done that, continue, get the value, solve for the BH. And you're welcome. Yes?
Oh, I'm just keeping my.
Oh, okay. So, okay, fair enough. Did you break it or cut it?
I had surgery on it.
Oh, right. I knew
After
that.
I broke it.
Yeah.
Which one?
So I'm just, since it's a bit so
Any bionics?
Too bad.
Get metal pieces?
they put a pin up in it, but they're gonna take it out.
Oh, why?
It's just in there so it grows the right way, and then I'm going 3 weeks to take the whole.
Well, yeah, keep it in there. Stronger. Better. Faster than you were before. Punch harder.
I'll be able to play rugby after.
You'll be what?
I'll be able to play rugby like before then.
It'll heal fast then.
It's only 3 weeks.
In your
out.
professional opinion, who are the most and least smelly science people? Like, based on
Mine is like-
Oh, ooh. I would say the least smelly. It's hard. Because for the biologists and chemists, it didn't have to do with hygiene. It has to do with what you're working with
No,
in
I
the
mean,
lab.
like,
So the
hygiene.
biologist, you can't tell. They smell of formaldehyde all the time.
No, I mean, like, just hygiene.
I give the biologist the edge there. Not in smelling the least, because they're often outside.
Also, biologists, like,
Like they go and like take samples.
wouldn't they also, like,
Yeah.
be aware
So,
of...
They smell of moss and bark.
it is that. So, where do they rank? I'm confused.
Oh, so it'd go like physicists and computer programmers, same people, and then above them sometimes mathematicians. Depends on the mathematicians are weird because they're either completely fastidious or it's no in between. And then the chemists, and then the biologists. But often it's because you can't tell because they've been outside and they're wearing like, they look like lumberjacks. But if they work in the salmon industry, it's awful.
What about engineers? Where would you place engineers?
Engineers aren't real scientists.
I'm not saying
They're Lego
Okay, where would you
people.
put, like, medical sciences?
But, like, I'm just, like, talking about, like...
It's just
all
like
the-
surgeons aren't real doctors.
Big Bang Theory.
Yeah, but, like...
What?
Like, where would you rank, like, all the STEM majors, like, in terms of, like,
Then why would
smelliness, like...
and surgeons aren't doctors?
Okay, least smelly, right? No. Psychologists and anthropologists.
Yeah.
Like
Okay, well,
they're
that's-
like regular people.
What about, like, doctors? and things like
Doctors?
that? Where do they rank?
Doctors will be good. They will have no social skills, much like the engineers.
I didn't ask that. They're smelly.
Yes.
Surgeons aren't real doctors. Why do they get paid so much?
Because they have that ego. You have to like give them the money or they won't work. The surgeons, like they don't actually go to medicine. They fix parts. They're a mechanic. Yeah.
Yeah, but none of us know medicine. We just, like...
Oh no.
We just give the body some...
The only the people who know the medicine are the biochemists, which happens to be my degree. The biochemists are the ones who actually knows all the interactions that are happening. My favorite course is Biochem 300 because at that time I'm doing a double major in biochemistry and chemistry, so I have a ton of pure chemistry by this point. Biochem 300 is the mandatory course. You don't have to take any chemistry or anything, but if you wanted to be a doctor at UVic, or was it UBC, you had to have like the equivalent of Biochem 300 in your portfolio to apply. So every doctor would show up for this one course, and maybe the last chemistry they took was chemistry 12.
I'm sorry.
And they were so panicked. It was hilarious, because I, as a chemist, could make fun of them.
Did you go to UVic and UBC, or did you just not remember?
I went to North Island College for a year, I went to UBC for a year, and I did the rest of it at UVic.
Okay, I just
Why
like,
did you
just, like didn't
transfer out?
remember which one.
Pardon?
Why did you transfer around so much? Like, just...
I didn't like UBC. It was too big. I've been told by people from like back east schools, like UBC is a quaint little university. I'm like,
What?
for me, I grew up in like Black Creek.
No, like, UBC's...
the biggest university in Canada in terms of their people.
It was huge. It was sprawling. I didn't like Vancouver very much, but UVic was like cool. Like it was small and had a little ring road, and you could get to all your classes.
I don't like the
And what drew me from there is that at the time UBC didn't have a co-op program. I don't know if they do now, and UVic had a chemistry co-op program, so I transferred straight into that. I have wasted enough time. You need to finish that. Calculus pH.
0.003.
No.
2.5.
Wait, oh,
Close.
that's, sorry, X. Oh, you mean
Yeah, you need to calculate.
Wait, of pH of, okay,
0 point.
which one? Which one?
Go do this.
What does x equal?
0.003.
0.00300, which is also equal to the concentration of H plus. Always double check, because remember this could have been in a different type of problem, like x, 1 minus x or something. Also, we can now look. 0.003. That's way out here in our doubt. We're always plus or minus in the last digit. So yeah, we can make that the thing.
Okay, so then the pH would be 2.523. It's 2.66, right?
Actually, it's 2 sig figs.
Wait. Oh, okay, so then it'd be,
Only because of this one, I just noticed that.
oh, so then it'd be 2.52.
Yeah. Not molar. What am I doing? Sorry.
What?
I wrote an M at the end out of habit. Now immediately in your next math class, when you're solving a problem, you are actually, technically, you can use that statement at any time. Just let this equal that. Why not? Try it out, see how it goes.
Why are you trying to
I
take my
showed
math?
that to Ms. Walensky. I think I broke her for the evening.
Why?
She was like, why would you do that?
Why are you trying to tank my math grade?
Yeah, but in math, we're trying to be like accurate,
No.
like very
No.
accurate.
In math, you're trying to lie. Do you know the answer beyond that? No. Can you? Because mathematicians say, oh, this is 2.52, blah, 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 blah. It's not. We're centered in the real world. They're centered in made-up fantasy land.
So
Made up
if
fantasy
math was
more
actually, if math was like found, then it would give that value because
Yeah, it would be the real value. Yeah.
the real
Yeah.
value.
Science is empirical. We rely on data. We know where the truth begins and ends. Mathematicians just pretend everything is the truth.
I mean, like, are atoms real?
Yep.
Yeah.
How are
seen
you
one?
alive right now? What?
Have you seen one?
Yeah. Well, we've seen pictures. I mean, you could say that anything. Right now, you're not seeing anything
Yeah.
because you have a lens which is taking the light, it's flipping it upside down, it's projecting on the back of there, where you have neurons that take the signal to your brain. So the light, you never see the light, you're interpreting the signal. You could be stuck in the matrix someday with something glued to your eyeballs presenting you with this, or just feeding it directly into your brain. So at a fundamental level, it's real in so much as we define real.
Can you go back up?
Yes.
But there's always like a certain aspect of like guessing.
Pardon?
It's a theory, so it's all like certain.
A theory is a well-supported statement by multiple lines of evidence for which we've derived an
But it's
explanation.
not a fact. It's not a rule.
A fact is an observation.
Yeah. But it's not confirmed. If it's a theory,
What?
But
if it's
if
a
you
theory,
see it,
then it's
is
not
it not
confirmed.
real?
We know, but hold it. Theory of evolution, germ theory, theory of gravity.
Yeah.
We use the word theory and the way we use the vernacular in like, I've got a theory how this happened. That's like common usage, but it means guess. But in science, theory means a well-established a well-established explanation supported by multiple pillars of evidence. So like the theory of evolution is well supported. The theory of Brunson-Lowry chemistry is well supported by multiple lines of evidence. What you're looking for is the word hypothesis. So the fact that we exist is well supported by multiple lines of evidence. Now, can you
But there's
rule
also
out
evidence
everything
against
like you're in the Matrix? No. But we wouldn't call that science either. Anything that you can make up that you cannot disprove is just an unanswerable question. It's not considered the bounds of science. I mean, we don't even have to go that far. We can say the entire world's magic and you're just an imagination in some singular being's head. Sure, it could be, but there's nothing to confirm it. So, by all tests, yeah, we've got atoms to the point we've seen them with not microscopes. We can now electron microscopy atoms and make shapes out of them. That was like a decade or so. So we have seen them. Okay, you done?
Yeah.
We can skip this page because I gave the explanation on this page. And now we can start doing this. I'm just glad I got to show you the most awesome section of chemistry. How many of you have math next?
Me actually.
Excellent.
I have one.
I would like you to show your math teacher. Show them what you learned in chemistry class. Why are you laughing?
Why can't I laugh? Maybe I feel joy.
I always get nervous. They're laughing at me.
Tutorial today?
It's Saturday. There's no tutorial on Saturday.
No, like, are you in?
Oh, I'm on duty today. If you dropped by in the afternoon, yeah.
Because yesterday you were there.
I was helping a student in the house, it turned out. I went back to the house to find a student, and then I got grabbed and I had to help him with house things. So yeah, I got back late. I apologize. Yes. Oh!
I know. Are you done?
Yeah.
What was it?
Thank you.
Where's
Thank you.
my phone?
Why?
Take a picture.
Of my goggles?
Yeah. I'm gonna show them to Ms. Stewart.
Uncomfortable.
I'm gonna take a picture of the
I know,
sides.
get from the top, you can see how it like goes in.
Yo, Eric, is my
Yeah.
collar good?
Let's see.
That's cool. They didn't take long to arrive at all.
No, it
Yeah,
isn't.
Yeah.
The blue light isn't as strong as my actual glasses, but
Oh, I'll do this.
why?
Because I have a big head. It will stretch it.
Oh.
I don't really know difference.
We'll try it with my actual.
But I don't
Like, see, these ones
I
are
don't
stronger.
use blue light goggles.
Well, you'll be able to see the difference visually.
There's
Oh, okay. You're colorblind. You're colorblind.
it's not.
Actually, I painted something the other day
Yeah.
using them. Color theory. again.
Oh,
I
yeah.
took them
And
off.
then you yes.
And something was like, oh, they're fine. I'm like, well, they're very warm. He's like, it's not very warm. And then I got to put my glasses on. He's like, oh, you're right. This works better.
There's a whole section of art I saw once. You know the really yellow outdoor lights that make
Yeah.
everything look weird?
Yeah.
There's a whole section of graffiti art which is only intended to be viewed at night under those lights because it doesn't look normal and you can't really tell what's going on unless those lights are there. Because they'll
actually
paint
can't
it with
tell the
stuff that washes out and reveals what the design
You
actually
can't
is.
tell the difference.
Yeah? No, I can't.
Stare up at the ceiling lights while you do it.
Yeah, no, it looks
No,
the same.
I mean, like, stare up at the lights and change. Just pay attention to the tone around it mostly.
Oh yeah, it's a little yellower.
Yeah.
Yeah, I can see the difference now. When I look right at the light.
We weren't laughing at you. We only laugh at you sometimes. And it wasn't. Today was not one of those times.
That's all good.
What?
That's all good. At least the class was going. We got the main thing done. It was exciting.
Okay. Bye.
See you. Enjoy our next. Do you have math next?
No, I have biology.
Oh, okay.
I'm gonna go, and then afterwards, my mom's gonna pick me up because I was fired from watch a drag show.
Oh, nice. Oh, that's right.
And then the next day I'm going to. Yeah.
I hope that goes
Bye.
well. See you. What? What is this? What's this doing? End stream.